Hello, welcome to Unit 4 Practice Problems Part 1. In this video, we're going over EVT, MVT, and concavity. So for the first question, it says find the absolute min and max on the interval -3, 1, and it gives us this function right here. So the first thing that we want to check is to make sure that there is no break or any discontinuity in the equation itself. And so we can say that because y is a polynomial, it is continuous and differentiable. So this is to prove that EVT can in fact be used to find both the min and the max on the interval. So the first thing that we want to find is any critical points. And the critical points are basically where the graph changes from increasing to decreasing or decreasing to increasing. And when the graph does, it makes either a max or a min. So the first thing that we need to do to find that is, because we know that a max or min is formed, the derivative would be 0 at those points. So we need to find the derivative and make the equation equal to 0 and then solve for x. So the derivative of y equals -3x squared minus 12x minus 9. And then we can take out the -3. To get x plus 3, x plus 1, x equals -1, and -3. And next we need to make sure that these values are actually on the interval. So the only one that so they're both on the interval. So we need to make sure these values are on the interval, and they both are -3 and -1. And now the next thing that we need to do is make our t-chart. So in our t-chart, we need to make sure we include the two critical points and the interval. Luckily for us, one of the values of the interval and the critical points are equal. So we have -3, -1, and 1. On this side, we need to plug in these values into the original equation to see which ones are maxes and mins, and which one is the absolute max and the absolute min. So if you have a calculator, then it will be very easy. I do not, so So here we have our 3 separate points. And so we can tell the min is 1 and -13. And then the max would be -1 to 7. And then this point right here would either be a relative min or relative max. We don't know. So we can write it as max at 7, where x equals -1, and min at negative 13, where x equals 1. So these are our two answers. So let's just move this. The next question says use mean value theorem, and it gives us this function right here, and it gives us a specific interval. So the first thing that we want to check is to make sure that this interval, or this function and this interval, don't have any discontinuities. So what I mean is there's no hole or break or asymptote where x is 1 between 1 and 5. And so to do this, we know that wherever f of x is 0, because 5 over 0 is undefined or does not exist, then we know that the function won't exist at that one point. And because 1 and 5 does not include 0, then we know that the function is continuous between 1 and 5, but just not where 0 is. So to find the mean value theorem, we basically need to find the slope between 1 and 5 of the x value, and then find a specific point on the graph that equals that same slope. So the first thing to do is find this slope right here. So we have f of 1 equals 3 minus 5 equals negative 2. And f of 5 equals 3 minus 1 equals 2. And so the slope is the derivative of f of c equals f of b minus f of a over b minus a. That looks like a lot, but really you just need to memorize change of y over change of x, or the slope formula. So we know these, and we can simply plug in derivative f of c equals 2 minus negative 2 over 5 minus 1, and that's 4 over 4, or 1. The next step is to find the derivative of f of x, and to do that we can use chain rule. So 3 is 0 minus, and for this we can do, so negative 5x negative 1, and then we can change that, do chain rule to 5x minus 2. So it would be plus 5x minus 2. And that's basically 5 over x squared. And if we change that to 1, so make that equal to 1, we get 5 over x squared equals 1, or x squared equals 5, or x equals square root of 5 plus or minus. And we still need to check the interval and make sure that it would exist at those points. And because negative numbers are not included in the interval, we can get rid of that negative, and we are left with x equals the square root of 5. And the last question is talking about concavity. So it says determine the points of inflection and concavity of h of x equals x to the power of 3 minus x. So we can do the first derivative of h equals 3x squared minus 1. And the second derivative equals 6x. And so to find points of inflection is similar to finding the critical points like we did in the EVT question. And so if the derivative graph has a min or a max, so if this was the derivative graph, then wherever there's a min or a max would be where the second derivative equals 0. And if the first derivative has a min or a max, then the original derivative has a point of inflection. So we can use this knowledge to find where there's a concave up and a concave down. So 0 equals 6x, x equals 0. And now we need to establish intervals. We need to establish intervals. So 0, 0 to infinity, and negative infinity to 0. So we need to plug into the second derivative function, and if the outcome is positive, then there's a concave up, and if it's negative, there's a concave down. And we also need to make sure, because x equals 0 is a possible point of inflection, so to prove that's a point of inflection, there needs to be a sign change. So derivative f, we can put 1, second derivative, and then second derivative, we can put -1. And we don't need to actually solve, we can just use math to figure out if it would be a positive number or a negative number. So if we plugged in 1 over here, we would get a positive number, and if we plugged in -1, we would get a negative number. So we know that x equals 0 is a point of inflection because the second derivative of x equals 0 and the signs change negative to positive. And then we also know that the interval negative infinity to 0 is concave down, and 0 to infinity is concave up, because the second derivative is, let's make space, because the second derivative is less than 0, and because the second derivative is greater than 0. So we found concavity and the point of inflection. Thank you for watching, and stay for part 2.